This is section 1.4, which is solving by graphing. And with my students, I've already been over this, but you solve an equation by graphing by treating the left-hand side as its own equation and the right-hand side as another equation. Now, the grid I gave you here only goes up to 11, but if we're going to do this guy, which is literally mx plus b, we're going to have to go up to 14. So 12, 13, 14, we'll put a point. And then we can use some common sense. The slope is to fall 3, run 1. Well, if I fell 2, if I ran right twice, I would actually fall 6. And 14 minus 6 is going to be 9. And I would have run over 2 places. Anyways, fall 3, run 1, fall 3, run 1, fall 3, run 1. So 9. Here's the issue with graphing, like obviously. The other issue is I don't know what 14 minus 6 is, and it ain't 9. It's one of them days. It'd be 8. Alright, so that makes more sense. Just having a moment. We'll call it a senior moment. Now, the other guy is 5, and this is based off, the mama function, y equals a constant. Horizontal line crosses at 5. You can also think of it as mx plus b with no slope, all run, no rise. So it would be right there. And it is a straight up horizontal line. Looks like this. Of course, you're freehand graphing here, but there's your solution. Your solution is at x equals 3 because that's where the y values are the same. That's where the output is the same. That's why we call it a solution. And, most kids I don't think ever realize why we call these things a solution. We call this a solution, x equals 3, a solution, because the output, which is y, is the same for both. And, it'd be kind of silly to even do this one by graphing. It really would be. We would have taken away 14, negative 3x is negative 9. And we would have divided out the negative 3, and we would have got it just like that. It's a two-step equation algebraically. But it's a good intro for how to solve by graphing. So here's one that's a little more advanced. Not every one of my students knows their mother function is worth a darn. Not much I can do that. And not every one of my juniors knows how to do mx plus b. Like, it's a real deficit y'all have developed. Like, I wish you could go back in time and just kick yourself right in the rear end and make yourself learn the content instead of just barely trying to get by. And it's a huge problem with education in that we promote you when you don't know anything. We are literally failing you by passing you. Isn't that a weird concept? Anyways, I am graphing this guy. I'm treating this as a y equals. That's a shift right 4. Initial slope is 1. And then we have the half x plus 1. I'm probably going to wish I would have put some more points here because my v is not entirely straight. It's not as straight as it needs to be. You're solving by graphing. The more dots, the merrier. Because you need to see those nice intersections. And it's really easy to get off. So anyways, I did y equals the absolute value of x minus 4. That was a simple shift right. We had the understood 1 in front. That was my slope. Now I'm going to do y equals 1/2 of x plus 1. And again, that is mx plus b. We cross the y-axis at 1. And then we rise 1 and run 2. We rise 1 and run 2. I'm just going to keep going for a while to see if there's a second answer, and there was. And this one has 2 solutions. This has a solution at x equals 2, 4, 8, 10. And at x equals 10. 2 answers. Now, just because, why not do it by hand? I almost think on your homework I make you check it by hand. So algebraically, okay, the absolute value is by itself, and that's the goal. So we write 2 equations. X minus 4 equals 1/2 of x plus 1. Or, and hear me out, negative x plus 4 equals 1/2 of x plus 1. Remember, we changed the sign on the stuff inside. So let's see here. Let's move our x's to the left and our numbers to the right. You know, this would make the left-hand side x minus a half x. Because if we jump equality, we change our sign. And the right-hand side should be 1 plus 4. Now, x take away a half of x is a half of x, and 1 plus 4 is 5. The opposite of multiplying by a half is doubling. So we're going to double both sides, and we get that x is 10, which I have. Over here, I think I'll shift my numbers to the right and my x's to the left. Sorry, I said that backwards. I'll shift my numbers to the left and my x's to the right. 4 minus 1 is 3, and 1 half x plus x is going to be 3 halves of x. Now, you know, by hand, what you do is the opposite of multiplying by 3 halves is 2/3. We do opposites. And the 3's cancel, and that gives us the 2 as x. That's just one of many ways to do it. All right, how can you use a graph to solve an inequality? So we are supposed to solve x squared minus 4 is greater than 0, and there's a lot of things here that are from Algebra 1 that you have likely forgotten. But first step is to rewrite a quadratic in standard form, and that one is in quadratic standard form, so we don't have to do anything. It might make sense, though. The reason I mentioned this was because a lot of kids don't understand things that are there. And it is understood that there is a plus 0x in there. All right. Now, we're going to find the x-squared on the vertex using something old. It's called opposite b over 2a. By the way, a is 1, b is 0, and c is negative 4. So the x-squared on the vertex is at opposite b over 2a. So b is 0. Opposite of a 0 is still a 0, divided by a, which is 2 times 1. And 0 divided by anything is still 0. To find the y-coordinate, we take that x value and we plug it back in. So the y-coordinate is going to be a 0 squared, and then just minus the 4. And all we get back is negative 4. Now, we actually knew how to graph that one with transformations, because it was simply a shift down 4 and draw a parabola. But there's where the vertex is. No surprise there. The x-intercepts are found by setting the equation equal to 0, and we're not even going to use open dots on them, or solid dots, because it talks about being greater than 0. But anyways, x squared minus 4 is bigger than 0. There's lots of ways of solving this one, and we're supposed to set it equal to 0 to find the zeros. But let's just shift the 4 to the right. And then let's counteract squaring by square rooting. And remember, when you take the square root of a number for something that's x squared, you have to have two answers. And the square root of 4 is plus or minus 2. So there's solutions here at 2 and negative 2. Technically, I probably should have dashed some of this out. I probably should have used open dots. But that's the graph of x squared minus 4. Now, greater than 0 is basically saying where is the function positive. The function is positive there and there. And these are inequalities, and inequalities are answered with inequalities or interval notation. But the x values that make this true are anywhere from negative infinity all the way to negative 2. And it might make more sense to answer this using the inequality, but negative infinity to negative 2 is one group of solutions. This is x is less than negative 2. The right tail is positive 2 or more as you move right, so union with 2 to infinity. Or x is greater than 2. Set builder is kind of easier to use on these because you basically just have the inequalities. But pick your pill, kids. Pick your poison. Alright, what do we got here? A motorcycle is 40 miles ahead of a car. The motorcycle travels at an average rate of 40 miles per hour. The car travels at a rate of 60 miles per hour. When will the car be ahead of the motorcycle? Won't take too terribly long, now will it? It'll happen. Alright, so let's see here. A motorcycle's got a head start. Notice I've got these gridded by 20. The motorcycle starts at 40. And down here is just 1 for hours. And the motorcycle is going 40 miles per hour. So, in 1 hour, it's going to go up to and over 1 because each tick mark is 20 miles. up 2 and over 1, up 2 and over 1, up 2 and over 1. And that's the motorcycle's graph. Now the car started at 0, but it's going at 60 miles an hour, so it's going to rise 3 and run 1. Now it hasn't quite caught it. It's close. It's going to rise 3 and run 1. And that is where the intersection happens. So, will the car be ahead of the motorcycle? Anywhere along this path. It caught it by the second hour, but past the second hour is when it's true. So for x value is greater than 2. And we should really be saying for time greater than 2, because it's about time. It's not hard. Algebraically, what you would have done is you would have said 40x plus 40, that's mx plus b, and then compared it to the car. We want to know when the car is going to be ahead of time, 60x. And I should have put a 40 there. Jump the 40 over, you get a 20x greater than 40. Divide by 20, x greater than 2. So as long as your time is greater than 2 hours, there's the algebra behind it too. Alright, use a graph to solve each inequality. So back to this one, we're going to find the x-score on the vertex by doing opposite b over twice a. Opposite b would be -6 because a is 1, b is 6, and c is 5. And I know it's going to be hard for some of y'all to pick out your a, b's, and c's because you can barely say them. A is 1, 2 times 1, -6 over 2 is -3. To find the y coordinate, you take that number and you plug it back in. And you will sit here and moan and complain that you did not do this in Algebra 1, and I know full well you did. A -3 squared is 9. We're going to take away 18 and add 5 back. 9 and 5 makes 14. Take away 18, you get -4. This one has a vertex at -3, -4. So left 3, fall 4 is my vertex. I'm going to find our zeros by setting it equal to 0, and this one will factor, so we will factor it. Not all of you can factor. You came into Algebra 2 with a huge deficit. I've been trying to give you a little bit of factoring practice, but you just don't want to do it. Anyways, it takes an x and an x to create x squared. It takes a 1 and a 5 to make a 5. And they're both positive because we have to add the 6. Now we get to use what's called the zero product property. We take each particular factor and we set it equal to 0. And they're both simple equations. We're just going to subtract 1 and 5 respectively. So we have intercepts, x-intercepts at -1 and +5. And here is my parabola. And the deal here was, where are we greater than or equal to 0? So we actually get to include that dot there, the x-intercept. So we're greater than or equal to 0 from -5 to the left. That's the left tail. And on the right tail, we are -1 to the right as far as x is concerned. So it looks like that. Or if you're a set builder kid, all values of x such that x is less than or equal to -5, comma, x greater than or equal to -1. Close the braces. Moving forward, using technology. So you should be able to do this, but I have found by and large that if a kid barely comprehends y equals mx plus b, they probably can't use a calculator either. I don't get it. I don't know. Be right back in just a second. I need to pause real quick. So I've got a set of instructions here. It says press y equal, which I've already done. Enter the left-hand side into y1, which I have done. And enter the right-hand side into y2, which I'm about to do. Now, the absolute value function you find by hitting the math key, scrolling over to num, and there she is, ABS. And you're just going to type in x minus 4. I got a homebound kid. I guess it's time to get you a calculator, probably. Anyways, from here on, it says press zoom and choose 6. You by default do a zoom 6. You don't hit graph. You hit zoom 6. And just like that, the TI-84 is going to do some graphing for you. And this one I think is going to have two answers. It's going to have an answer here and here. And we don't just guesstimate. Instruction says hit second, trace, scroll to 5 for intersect. Now, find your cursor. I'm going to press the right button a couple times till I see it. And once I get close, I'm going to press enter 3 times. So once, twice, thrice. And there's one of my answers. Let me just snipe this so I can save it for later. Snip it, snipe it, whatever you like. Alright, let's go through the process again because there were 2 answers. Second, trace 5. Take your little cursor, get close, press enter once, twice, thrice. And there's the other solution. Now I want you to get in the customary habit of rounding to the 4th decimal place. I'm a big stickler about 4th decimal place because these are rounded answers. And they do represent a fraction, I'm sure, because the decimal is not repeating. That one could possibly be. Anyways, try and go out about 4 decimal places. Double squiggly, it tells the end user, the person looking at your work, that you rounded 2.6972. Maybe you're one of those classes that can actually round. We'll call that x1 because it was one of the x's. We'll call this one x2. And it's about 5.3028 if we can round properly. And you'll notice that we had equality actually in both of those. This one had quite a bit of symmetry going on. And there's another one of these, but I'm not going to do it. It's a you try. I only need to see that once. From then on, you more or less just have to do it yourself. Alright, there you go. There is 1.4 using graphing. Solving by graphing. Man, I'm tired.